1, record. All right, let's analyze projectile motion. If we launch an object at an angle theta, gravity is going to act on it. Gravity acts on it to slow it down as it is traveling upward and to speed it up as it's traveling downward. If we launch it at an angle theta, it's going to have a parabolic shape like that, and you have to launch it at some initial velocity, v0. If you launch it at an initial velocity v0, it will have components of velocity in the x and y directions. The x direction we call v0x, and in the y direction we call that v0y. Now the angle theta will be located here, and since x and y are the x and y axes, this would be 90 degrees there. Now v0 is the actual velocity that's made up of these two component velocities. So this v0x is the velocity in the x direction. And this velocity is constant. It stays at a constant velocity as it travels along the parabolic path. So at any point along the path, it is the same velocity. And let me draw that in a second drawing here. And we're going to pay attention to that velocity on the inside of the path. As you go over, you go up. And as you go over, you go up. But notice, if you go over the same amount each time, you're going up a smaller amount each time. Now, the x component, if it stays constant, the y component can't stay constant as you travel up the parabola. Normally in a book, you would see this drawn like this on the outside, so that the x component would be on the outside and the y component would be like that. And my problem with that is that you can't visualize that the y component is actually decreasing on its way up and increasing on its way down. This is representative of gravity slowing it down as it travels upward, and gravity increases its velocity as it travels downward. Now, we can take this triangle and separate it off to the side and analyze it using sine and cosine. And if we do that, we redraw the triangle. This is v0x, this is v0y, this is v0, this is the angle theta, and that is 90 degrees. Sine theta is equal to v0y over v0. Sine theta is opposite over hypotenuse. Solving for v0y, v0y is equal to v0 sine theta. And you can analyze v0x using cosine. So cosine theta is equal to v0x over v0. Cosine theta is adjacent over hypotenuse, so v0x over v0. Solving for v0x equals v0 cosine theta.